Okay, the tricky thing about this last example is that it bends. So the longest chain ended up going this way for us. That was the longest chain there. And then that methyl, that was handy, wasn't it? And then that methyl was our branch. So our longest continuous chain was 1, 2, 3, 4, 5 carbons long. So that ended up being pentane, right? And the branch that you have named is, you've already got these answers right in front of you. So methyl, and it was on carbon 3. So 3-methyl pentane. All right? Okay, so carbon tetrachloride. What do you think? What can you piece out of that? And I've called it or tetrachloromethane. What can you piece out of that name? What hints does that name give you? There's 4 from the tetra. Still not doing it for me. 4, please. 4 chlorides. Everybody okay with that? What else can you tell me? Methane. So what does methane give me? 1C, 1 carbon. So then you put those pieces of the puzzle together and you end up with 1 carbon with, how many sticks are on carbon? 4 sticks. And oh, that's kind of handy because how many things have I got to put on the sticks? 4. Oh, so Cl, 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 Cl. Yes?
Is that still a hydrocarbon because you said hydrocarbons are only HC?
Hydrocarbon, no, this is not a hydrocarbon. What would this be? A hydrocarbon derivative. So who's heard of chloromethane? Or chloromethane, I suppose it's probably pronounced here. Yeah. And tetrachloromethane, no carbon tetrachloride. Okay, it's a normal common solvent. Polar or non-polar?
Non-polar.
Non-polar. Okay? So you can, it's a nice oil-based to dissolve quite a few things in. Right, so carbon tetrachloride is one that they like you to know as like a common chemical that you will find when you read the ingredients list on quite a few things. Obviously not something you eat, but something you use. Okay, so carbon tetrachloride is a solvent that's used in quite a few oil-based things you might, like paint, for example. Okay? And so that's what it looks like. So carbon tetrachloride or chloromethane or tetrachloromethane. All right, so let's try these next examples. We'll go, thank you. Try these next examples on your own. And I'll give you the answers in a minute. Do 1, 2, and 3, I suppose. Well, do them all, but and I'll give you the answers. Okay? Do you want a bit of help, or are you good? You're good? Okay. No problem. And so yes, there needs to be an H there, of course. This is 1, 2, 3, 1, 2, 3, 4, 5 carbons long, so that makes it pentane. Here is your methyl branch. I can number them the way I have in green, or I could number them this way, 1, 2, 3, 4, 5, but then the methyl being on carbon 4, and we want to go with the lowest number, so we're going to pick the green numbering system, and it's 2 dash methylpentane, all one word. That's pentane, methylpentane, one word. Okay? This number 2 now, I am going to have my longest continuous chain go like this. Or yours could have been looking more like a 7. Doesn't matter. You still get the same answer. You've got 1 methyl branch. I could number the carbons 1, 2, 3, 4, 5. Or 1, 2, 3, 4, 5. I'm going to number them this way, 1, 2, 3, 4, 5, so that the methyl's on carbon 2, which is the lowest carbon. So therefore it's 2 dash methyl, how many did I have there? 5 pentane. Oh, look. Look. Question 1 and 2. Are they named the same? They must be the same molecule. They are the same thing. this one just happens to be turning different than this one. Their pictures look incredibly different. When you say, like this green and this red look very different. But they're named the same, so they are the same. So why do they look so different? Because you're trying to represent a three-dimensional thing two-dimensionally. Have you finished, Abby? So Abby's drawn this molecule for us. Or not drawn, I mean, what do you call this? Structure, built. Thank you very much, Evan. Built this for us. Okay? So this is what it looks like, three-dimensionally. Pretty, like, crazy. So when you flatten all this out, and you put the bend, let me just see, the first one has the bend kind of here, like that, poking down. So there's my methyl group holding on. We're missing one here, Abby. I need a hydrogen with this on the stick. So if I hold the methyl down like picture 1 is, it looks like this. Okay? Whereas picture 2, I have like a T-bar and the rest dangling down like this. Do you see that it's the same molecule? Okay? And so Lindsay said, and Raj said, how do you know it's the longest continuous chain? Well, because if you're trying to make a line, this is one line or that's one line. So there's a line. The longest line wins. So the answer to how do you know that it bends isn't really a fair question. But you can catch yourself out because you shouldn't have a methyl at the end. If you have a methyl at the end, like one methyl, blah, 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 it must be part of the chain. You see that? It must be part of the chain. Or even dimethyl, one of those has to be part of the chain. Okay, so they look completely differently. And I don't expect you to be able to look at the CHs for one and look at the CHs of 2 and go, they're the same. I do not expect you to see that and think it looks like this. I expect you to be able to name them, and once they're named and they are the same, they must be the same compound. If you come up with the same name, it's the same thing. It's just like you doing a cartwheel. You're going to look differently at each freeze frame of that cartwheel, but it's still you. Okay, so these are the same molecule. All right, so number 3 then. Is that the longest continuous chain? So somebody asked me, but how do I know that this isn't the longest continuous chain? It's the same. And the person that names it, that draws that as the continuous chain versus the person that draws that as the continuous chain, the yellow student and the blue student should end up with the same answer, the same name. Because you still identified 1, 2, 3, 4, 5, 6 carbons long. 1, 2, 3, 4, 5, 6 carbons long. So everybody's going to get, what, 6? Hex. Why is it AIM? Because they're all single bonds between the carbons, because it's an alkane. Okay, so now the question is, let's just pick one of the ways to follow it. Let's pick the blue way because, well, it's kind of easier for us to see things in a line. So blue is easier, but you still get the same answer. So this becomes, what are those branches called? Ethyl. And I have 2 of them. This is also an ethyl. And I have to number the carbons. 1, 2, 3, 4, 5, 6. So in this case, I have an ethyl on 3 and an ethyl on 4. Or 1, 2, 3, 4, 5, 6. I have a carbon on 3 and a carbon on 4. Oh, same thing. So that means this person, take it off the board, turn it around, same molecule, same numbering system. So you're probably going to pick the blue one because we like reading left to right on this side of the planet. And so the blue says 3, 4. How many ethyls? 2. So what prefix do we put? Di. So diethylhexane. So there's a comma between the numbers, a dash between the number and letter, diethylhexane all in one. Everybody happy with that one? And this one, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. Oh yeah, by the way, I also made a point on number 4 of changing these dashes into CH3 or H3C, doesn't matter. Do you see how, let me just rub it out. Do you see how this is the same as this? Okay? And you should be able to see it both ways now, or be getting used to seeing it both ways. Right, so back to the naming. Oops, back still my highlighter. So that's 7 carbons long. So that makes it, what, 7? Hept, ane, and I have to number this one right to left. So this is going to be carbon 1, 2, 3, 4. So I end up with 2. Oh, which do I write first? Ethyl or methyl? Ethyl. Why do I write ethyl first? Because it's alphabetical and E comes before M. By the way, that's regardless of the di's and tris in front. Okay? So I go 4, ethyl, ETHYL, 2, methyl heptane. Okay. Questions? Okay. So that is hopefully enough practice to put you well on your way for this. Except for question 1 throws you a definition that you don't know yet. I see. Okay, so an isomer, iso meaning the same, an isomer has the same molecular formula, different structural formula. Same molecular formula, different structural formula. So I'm just going to bring up some kind of blank sheet here. If I can. From one of these, this one. Okay, so for example, what is the molecular formula again? Do you remember from that long sheet that we did? The molecular formulas were C6H12, for example. All the carbons and hydrogens stuck together. And the structural formula was like CH3, CH2, CH2. Remember that? So it's a different structure with the same molecular formula. So for example, isomers of C, is it right, well we're going to do C4, H, 8, 9, 10. Okay? So isomers of C4, H10 will be together and then you can do that one on your own. So, C4, H10. How could you draw that very easily? It's just the most simplest. 4 carbons in the line. And then surrounded by hydrogens. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 hydrogens. Everybody okay with that? I'm not going to draw all the hydrogens in, but you should for proper communication, but there you go. Everybody get there's a hydrogen at the end of that stick. Okay. How else could you draw 4 carbons and 10 hydrogens if they're not? Oh, and what would you call that, by the way? What's that called? Bute, because it's 4. Ane, because they're all single bonded. So butane. Just like in that very long sheet where your hand got tired writing. Okay? What if I did this though? 1, 2, 3, 4. Same thing, Emily says quickly. Longest continuous chain. 1, 2, 3, 4. And therefore this is still butane. Are they the same or different? They're the same. So these are not isomers. Isomers are like kind of like cousins. You're going to think of these cousins. They're related, but they're different. They're related in the molecular formula, but they're different. These guys are the same. So what about this then? What about this one? 1, 2, 3, 4. Hydrogen, 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 hydrogen. Is it different? What's your longest continuous chain? 3. So what's this guy called? 2-methyl propane. Everybody okay with that? Are you going to have 10 hydrogens? Yes. Have you got 4 carbons? Yes. So it's still C4H10, but it is different than butane. So this and this are isomers. Butane and 2-methylpropane are isomers. Same molecular formula, C4H10, different structure. So in other words, if I got you to take out that box that's in front of Abigail right now, and I were to say, build one of these, and build one of these, you'd only need to go over to Abigail's desk and pick up 4 carbons and 10 hydrogens, and you could build that one, and then take them all apart, rearrange them, and build that one. You wouldn't need to borrow any more hydrogens or carbons from Abby. They're still C4H10, but they're taken apart and put back together a different way. This guy wouldn't be taken apart and put back. It's the same. It would look the same if you built that. Okay, now my last point. So those 2 are isomers, but the last point is this. 1, 2, 3, 4. Can there be a 1-methyl pentane? Is this called 1-methyl, or I mean propane? No. Is this called 1-methyl propane? No, because it's the chain of 4, and therefore this is actually called butane, right? So this is wrong. It's actually called butane because the longest chain goes like this. So the only methylpentanes that there can be is 2-methylpentane. There's no 1-methylpentane, there's no 3-methylpentane, there's no 4-methylpentane. There's only a 2-methylpentane. You get that? So and this is really important, so listen, even if you're working ahead, listen. On a test, might ask you to draw 2-methylpentane. And I won't, or pardon me, just methylpentane. I won't tell you the 2. I'll say, draw methylpentane. So you're like, oh, there's no number. I don't know what carbon to put it on. I don't know. This is what you do. You start with the propane. 1, 2, 3, prop. And there's only one spot to put the methyl. In the middle. So you're like freaking out. Oh, they haven't given me a number. The reason they haven't given you a number is because there's only one spot to put them. Do you remember us kind of talking about that last week? And I said, just wait. I'll give you an example. Now, for you, you can always put a number down. Okay? I will never mark you wrong. If it's the right number, you can put 2-methylpropane. So people are like, I don't really get what you're talking about, Mr. Brown. Just put the numbers down. You'll never make a mistake. However, I might give you a question without numbers. Does everybody get that one? Okay, so try the rest of that booklet then. Do the isomers for your question. And then I think that'll be, oops, oh, I can't go back to the sheet. But anyway, I think that will probably solidify your knowledge about alkanes, and we can have a quiz on it. So we've got the whole booklet to finish, and then we can do a quiz on me and alkanes. Yeah, well, I can't remember how much I've got in the booklet, and I can't call it up right now. But, ish. Okay? So we've got 45 minutes now to practice.